Hello everyone, I'm Mario and welcome back. So in this video, we're going to talk about topology. We're just going to continue where we left off last time. So just in case you missed it, we talked about the key principles of how to model anything. So we were talking about the understanding of tools, understanding of topology, and then understanding of form and function and why each of these on its own is very important, but as a whole it's even more important because without understanding the tools we cannot actually utilize or use the operations to create the topology that we want to, and without understanding the topology we cannot create the forms that we want, and then without understanding the forms we cannot actually create the functional or working design to actually put everything that we want from, let's say, a concept or an imagination into a 3D. So what you see here on the screen is just a like small bot project from Cinema 4D Masterclass. There is a small breakdown here on YouTube as well. But I just wanted to show something that it's already shown on YouTube, so you can refer to that as well. On the question that we had as a part of the series, how can I begin? Let's say that I see something very complex. Where can I begin modeling on anything complex, let's say, on more complex objects? So I just shared one tip that helped me in the beginning to, let's say, break down the objects into kind of like drawings of basic forms, if that makes sense. So what I would do is simply something like this. I would just follow either the form, follow the highlight, and then from there I would just break down the basic primitive that would be my beginning or starting point. If I maybe knew the primitive, if I would not be sure where to do cuts or where to do, let's say, edge flow, redirections and whatnot, then I would do also this kind of meshes or just trying to visualize my future mesh before even starting to do anything. And this helped me a lot, and also I just wanted to share that as well in hope that also helps you as well. So this would be an example. Let's say this is now the arm. We are trying to redo the arm from the basic blockout. Usually the blockout is going to be just something to bring the idea out. It doesn't matter how it looks. The proportions also not matter much. It's more about bringing the idea out and trying to figure out which shapes would determine the language of the design that you want to do later. So in our case here, if you come back to the drawing, this was just again something like, let's say, using a simple cube, subdividing the cube, and then from the cube I'm gonna stretch this out and then use booleans to break the cylinder on the inside. So this right here, which you see, so I actually can extract faces. This was actually started from a very simple cube, pushed it out, and then from that cube I created this form, and then in the end, once they intersect, then you're gonna use boolean. So let's say we're gonna have something like this, and then once you use booleans and then use the difference, you're gonna get this, and then it's going to be the matter of organizing and cleaning it and cleaning actually topology. So this again going to be the topic of this video, how to clean up and how to know which directions the topology actually needs to go, because how we actually know that the topology needs to flow in this direction, and why is, let's say, this direction bad, or why is this actually not working for us. So this is going to be more the how behind the how of topology. I also have here a couple more examples, so I can maybe remove this for now. This is also part of another question, and the question was, I'm trying to get a sharp corner here, but whatever I do, I just keep getting distortions on my surface, and I'm not getting the smoothness that I actually want to. So this is something that is the goal. So this is something that we're trying to achieve. And this is something that it's in our way of achieving the result. Now, if we isolate this, and if I show you the topology behind, we can also see that actually the flow of the topology is actually forming the highlights. So this is something that we also talked in a previous video. By understanding the highlight, we can break down the edge flow. And if we know the edge flow, the recreation of the object, it's going to be that much easier. So what we can see here is that the highlight is very, very strong. So here we can see that the highlight is strong in this area and is strong in this area. Here highlight is undefined, so it's not defined highlight, but it's there and it's showing sort of like a lumpiness in this area. If we can notice, I don't know if you can see it as well, but the highlight is going to be somewhere around this direction. So it's going to be around this area. So again, something that we really do not want. Another thing here on the third example is that the highlight is very, very strong around this area, but here is very smooth and very soft. So if we now check the mesh, or if we now check the topology behind it, we can also break down and see what is actually happening and why the results are the way they are. So in the first example right here, we can see that these edges are very, very condensed, and as a result, on a curved surface, they are giving us this highlight. The moment we remove these edges, so when they are no longer close to one another, we are going to get much smoother results. So we're going to need to take this into account. So using close edges only when we need, let's say, established highlight or when we need strong highlight. So this is the only time we're going to use two edges close to one another. So continue on to the second one. So the second example has condensed area right here. So here we have this kind of like redirection which forms this flow, and then as a result the flow is concentrated around this area, and again causing this lumpiness. So again, from this we can learn one thing, and that is we're going to use, let's say, topology that it's focused around one area only, let's say on the surfaces that are flat where we do not see any kind of deformation, or if we want to specifically redirect something in that area. So let me just demonstrate that a bit more on two of them. So let's say here and here, and now we can see what kind of results we get. So now it's much more prominent and the form is obviously visible simply because now we added the same what we have here. So two edges close to one another will form a highlight. Depending on the flow of the edges, we're going to get that highlight. And then the third and the final option, that is, so we have a pinching here and very smooth highlight on the other side. So if you break down that one, we can also see, let's say, this situation. So we have three edges there, three edges here. And when you compare the size of the edges, you can see that this one is more condensed and this one is more spread apart. Coming back from the first example, if we were to spread these more apart, so we would maybe lose the sharpness, but we would get the smoothness back. So we can also think about that and how we can use all of this, what we learned from all of these mistakes, and how we can use all of that into our advantage and create much more optimal topology that it's shown here. So here we can see that the highlights are very, very stable and that the corners are still relatively sharp and that we do not have any deformation. So the important thing to take away from this are three things: supportive loops, even spread, and then redirection. So these three key elements are going to be something that we're going to constantly manipulate in our topology. So supportive loop is going to be very, very simple. So supportive loop is basically just the general highlight of your object. So right now everything is falling apart like this. Now if this is something that we want to, then we achieved our goal. But if we want to have more of a established curvature or established highlights here and here, because right now everything is very sharp, for that reason we're going to add support loops. So support loops will go here, let's say all around. So let's say like this. I'm going to use bevel, chamfer off, and now it's more defined. We can go even further. We can define even these edges if you want to. Bevel chamfer off, and now we have more defined highlights in that area. So this is going to be the first thing, making sure that we have support loop. Second thing, what's going to be important to us is having the even organization of the edges, because again, this is going to be the most predictable way how we can deal with the edges. And then the third thing, what we're going to do is a redirection. Now, redirection might not be obvious at the very beginning, so we're going to now cover that. Now here also we can see that with the even organization of the edges, what I meant is that it's predictable, is that we can even now add more, let's say, more highlights to already existing curvature without actually impacting the curvature, and we're still going to have, let's say, nice smoothness, nice highlights, while still maintaining the sharpness. So here I have one example that I would like to share. And now this is going to be the question is, how do I know, for example, that this edge needs to go in that direction? How do I know that this edge needs to be here? Or how do I know that any of these edges needs to be exactly there where they are? So we're gonna cover this now. So let me just quickly do one thing here, nonlinear bend deformer. So let's say, okay, this might sound a bit stupid, but it helped me a lot to understand in which direction do I need to push the edges and why exactly in that direction. So you'll notice that this edge right here and all of these edges are perpendicular to the main edge. So this is our edge that is kind of like structural edge, it's forming the main outline, and every single edge on the inside is perpendicular to that edge. And the same thing here. So you're gonna have here main outline, and these inner edges are going to be more or less perpendicular to that outer outline. So imagine it's furthermore. So let's say that so this is also something that I mentioned before, but I think it's worth mentioning one more time. So let's say this is us right here. So this little guy. So you're, let's say, walking around here, and you're also walking around here. And whenever you stand, the gravity is kind of like sticking to you. So whenever you're standing, you're just sticking on a surface, regardless where you are, up or down, you're always sticking to the surface, and there's kind of like central gravity point. So this is the center of the gravity, and everything is pushing into that direction. So pushing to that center. So just imagine it like that. So this is again something that helped me a lot. And if we go from this point, so let me just now undo this and come here. So regardless of where you are, now you can see that the edge will always follow that outer form. And eventually, let me just also do one more thing, and let's merge these vertices. So the next question is going to be, these edges need to eventually meet somewhere. So the further we go, you can notice that they will probably meet in one point. So this is the meeting point of all of these edges. So just remember these two things. So gravity effect and meeting point. So how something like this would work on an object like this. So again, if we now compare these two, and I'm going to just remove some of the edges here that we do not need. So we can now cover it one more time. So let's say we are walking here, come here, and come here, here, and here. So just imagine whenever you're walking around, this is going to be your topology flow. So by that rule, topology will go that way, topology will go that way, and topology will go this way. So now you notice the meeting point, and the same thing is going to be on the other side. So the meeting point needs to happen somewhere. So if you just continue the meeting point, and then the meeting points is your topology. So there's your meeting point. So I can also use a different color. So meeting point, meeting point. And once you have that, then you have your flow set up. And now the only thing is to recreate that on the other side. So I hope that makes sense. But like I mentioned, this is something where I try to understand it for myself. Just try to see where the flow would be and how everything would connect to one another. So if we try to apply that rule, so I will just add, let's say, like we mentioned, we would need to have organized topology first to understand where everything goes. And maybe I can then remove these two just for the sake of simplicity, so I can know and reposition these edges a bit better. So now that we know where everything goes, I'm just going to reposition everything. So this goes here, and making sure in process that the distances between these are more or less the same. So this is going to go there. This is going to go here down. And this is going to go here down. And again, the same thing on the other side, just this is our meeting point. This is one side, this is another, and sliding it all down. And there we go. So let's say we have something like this. I already did that here, so we don't have to waste that much time. And now it's just a matter of bringing all of the edges, let's say, back that we previously took. So just making sure that we have even enough spreads everywhere. And then finally, what it's going to be missing is that support loop. So we can do it now, or we can do it later once we do the extrusion. But since we do it now, it's going to already be there, and we simply need to add 2 more extrusions there. And now we already step closer to, let's say, sharpening. The one thing here that I did, so let me actually undo all of it, because that's the step that I missed. And actually, maybe I can show you also in this one. All right, so again, a bit more organized. So the difference now between these two is that here every single corner is still soft. So this one, this one, this one, so we can also tighten these corners a bit more. So the way to do that, again, is going to be through the support loops. So again, if we offset this 2 more times, we're going to have more control on the top what to actually do with these corners. And then we just remove. So this is, again, depending on what you want. So if this is something that we would need to sharpen, then we would do it like that until we get this result, which finally, under deformation, if we want to check it out, it's going to deform, and we actually now manage to clean up the geometry while maintaining the same shape, and we don't have any more of these deformations on the surface, but instead we get clean topologies. So these were very basic examples on a flat surface and how everything should in theory go, or which edge should go where on a flat surface. But what would you do, let's say, if you would have a situation where you don't have a flat surface anymore, so you have now more sides to work with? And what would be now the situation here? So basically, it would be exactly the same way. If we would need to think about it, we would need to go from the top side and exactly do the same thing. We would just try to understand, so in which direction the flow would go and for what reason. So reason we now covered. And this would then be the flow. And this will be the direction, and now it's going to be just a matter of those meeting points and where everything meets. But the general outside flow, it's going to be solved like that. Same thing, it's going to be on the side. So if you need to think about what to do on the side, even though the side is, again, very, very similar, it's going to be super flat. So it's not going to be a lot of figuring out what to do. But again, the process would be exactly the same. So now the thing is going to be, either you want to redo everything, so remove and draw on your own, or simply try to sketch it on your own. So like we mentioned, this one would need to go there. This one would need to go here. It's just that I'm missing a mid loop first. So you would have something like this, and then just kind of removing the edges that you do not need until you get something like this, or like we drew before, then something like that, and then continue the rest. So just continue until the meeting points. This will be one way to do it. This is just, again, that visualization, what to do. Let me bring this back. The next thing is you could just, any triangle can be closed with the loop, and then you will get immediately the result that we have like this, and then it's again going to be the matter of adjustments. But this is now the basic rules that we covered, and knowing the rules sometimes also means knowing which rules we can break and which rules we cannot. So for example, let's say that I'm making a shape here, and I need, let's say, the shape. And if I push this to the side, it's not really working for me because I actually want this. So is this still considered as a bad topology? Really not, because everything is still in place. The only thing is that it changes, the flow changes. So this is the original flow that you're gonna get. So this is going to be the flow. And the only thing, again, that changes is simply the flow of the edges. Before, we would have, if I want to have this sharpened, I would have very, very sharp corner here. So let me also quickly demonstrate that because we want to do, let's say, a sharp corner here. So it's going to, the highlight is going to be pushed more to the side. So that's the only difference. The thing what I would like to have here, let's say I want to have a flat highlight there. So that means that the highlight follows the surface like this. So I'm not going to change that flow. So I'm going to leave it as it is because I simply need the highlight right here. And then I can do the same thing for every other part, and that it's going to be it. I mean, this is going to be at least the basic part of it all, because let's say again I would like to now do some more adjustments here, and maybe I want to push this even more down, tighten this more with the support loops, and get something like this. So there we go. So from very simple, just by following the simple rule, adding supports and making sure that we have a proper redirection, we can get the basic shapes pretty fast. So again, now we come back to that very beginning that we talked before. By knowing the highlight, if we know the highlight, we can understand better the edge flow behind it, because the highlight is going to be formed by the two edges close to one another. So again, coming to our situation from the beginning, this is the main highlight, that it's our structural highlight, so it's forming the structure. And once you know the highlight, you also know how to recreate the objects. Here we can see that the highlight is very soft, and for that reason we're probably gonna have more of a distance between the edges. And here where we see that the highlight is very sharp, that again means that we're gonna have two edges close together. And this is now again connecting everything to what we talked at the beginning, how to model anything really, and how to break down the object. So if you see a concept and if you see a complex object that you want to recreate, first things what we're gonna do is we're just gonna try and break it down, and following the highlight, by knowing the highlight, we're going to recreate the edges. When we know the edges, when we know the flow, it's going to be easy to find where that beginner shape is. Same thing as we've seen here at the bot example. So the blockout beginning shapes are very simple, and everything what is happening after this shape is just refinement. So after the blockout comes the refinements, and then the details, whatever details that are planned to do. So for example here, this is something that it's done very last. So whenever you're breaking down, let's say your model, so whatever you're breaking down, whatever you're trying to model, just imagine it without the details. So details are always something that comes last. The only thing that it's maybe worth keeping an eye on is the direction of the details, direction of the highlight, because that is in the end going to be the kind of establishing the edge flow that you're going to need to do. So it's always going to be the super basic blockout, the least number of polygons you can get. So you can notice here it's very little polygon number, just enough to get the idea out. and then later all that is getting refined, and then details and everything else that comes very last. So in the end, yeah, this is just a small basic introduction into topology understanding and how to manipulate edges to your advantage and how to position them properly to get the highlights you want. And then in the end, later you can either progress that way even more, add more details, or simply use these techniques to break down the objects into more simple forms and then start there. So the principles that we covered there here are going to be exactly the same for small objects or big complex objects, which again are just a collection of smaller pieces. So all of this is still built out of a lot of smaller pieces. So this is going to be one piece. So this is again one singular object, and then again here we're gonna have another. So this is now another object, and again here is going to be the third one. So no matter how something complex looks, it's still going to be built out of multiple singular objects that in the end form this kind of complexity. But in the end, all has very simple beginnings. So in the end, I hope that this cleared up some things, and topology is a relatively vast topic, so there's a lot to cover, there's a lot of practice. If you want to, you can always do this kind of like smallest 2D examples, practice there, see what flows goes where and how you would deal with that before trying anything complex. Try to break down smaller forms first before trying to break down complex forms. And yeah, the rest is just experience, time, patience, practice, and then everything later will just come in place naturally. So in the end, yeah, thank you very much for watching, and I'm gonna see you next time.